Last, we're going to talk about amplitude. Amplitude is what determines the wave's volume if you're looking at sound waves. So on the transverse waves, it is how significant those peaks and troughs are from each other. So this measurement here is considered to be the amplitude. So here has a low amplitude, and here has much greater amplitude because there's a greater distance between the peak and the trough. And when you hear sound waves like this, they tend to have a low volume. When you hear sound waves like this, you tend to have a much louder volume. Now, if we want to get technical here, now I'm not terribly comfortable with this, but the technical definition of amplitude is the maximum distance each particle is away from its rest position. Let me say that again. The maximum distance each particle is away from its rest position. So I've tried to visualize this on paper with some of those particle diagrams. So let's pretend we've got a tube here of air, and they're all evenly distributed across and random. So let's pretend that's the rest position. If we start to introduce some sound waves here, where we've got regions of compressions and regions of rarefactions, so I could see that a low amplitude here, where you can sort of see some semblance of slight compressions in certain regions on my little diagram here. And then for high amplitude, I've tried to exaggerate that, where most of the particles now are bunched up together in these compressions, and very, very few are found in these areas of rarefactions, meaning that if I had the same number of particles here as I do here, they've all kind of moved from their rest position, really crammed together away from their rest position, the original position.